All righty, everybody. Welcome. Welcome, everybody, from seed to sale, strategic and tactical microbe control for the commercial indoor farmer. My name is Jason Hadley. I'm with Filter Science. I'm one of the sales managers here. To give you a little background on myself, I have just under a decade in the cannabis industry myself, having worked all levels of position from trimmer to section worker to my own commercial grows. And if I've learned anything in my time here in the industry, it's that knowledge is power, and replacing apprehension and confusion with competence is always the best bet to stay in solution. So without further ado, let me go ahead and get into share mode here. And there we go. And let's start our slideshow. And from the beginning, there we go, I believe, slideshow from the beginning. Are we on? Do we see this? Technical difficulties? Just want to make sure.
There, I think.
Oh, there we are. Okay, great. All right, so snazzy cover, right? Again, from seed to sale, strategic and tactical microbe control for the commercial indoor farmer. So high concept here. The nature of the industry is changing. Compliance is forcing a lot of facilities to start to engage in practices that require consistency of producing compliant product. That process starts all the way at the beginning of the process. What we're trying to avoid here, guys, is the idea that you don't have to swing a chicken over your head and hold onions for prayer as you get to compliance testing. If you can build these types of processes and this level of awareness into the entirety of your process, as well as find ways to assess risks as you see them and do something about them, you're going to benefit in the long run. So what we're presenting today is a very high-level overview, I'll admit. There's a lot of questions and headings and bullet points that are going to come below that, but I at least wanted to make you familiar with topics around there. And of course, you can always follow up with me directly, or if you leave a question, I'll make sure to answer it. If we don't get to it today, I'll make sure to tag you in a post about it, or even respond to you directly. Also, just a quick bit of housekeeping. At the end of the the webinar, we do have a survey, 6 questions. We'd love to know your feedback about this and how we can improve these for gardeners going forward. So without further ado, let's go ahead and let's get started. So to tell you a little bit about ourselves, Filter and myself, Jason Hadley here, who we are. Filter's owned by Lighthouse Worldwide Solutions. Lighthouse is a leader in particle monitoring and microbe control. We specialize in real-time monitoring systems, particularly particle counting for clean room industries, which we'll get to in a second. But we also do research and development. We do pilot program production. We do service and installation, finance, accounting, quality assurance, and we are headquartered in Fremont, California. We also have our manufacturing facility in Medford, Oregon, where we do manufacturing. We do calibration, instrumentation services. We do system build out. We do system service, quality assurance, and of course, project management. But putting the worldwide in Lighthouse Worldwide Solutions, we do have a global footprint where, again, based in Fremont and Medford, we also have offices in Arizona, Philadelphia, and then globally in Thailand, Malaysia, China, Benelux, which is Belgium, Netherlands, Luxembourg area, as well as EMEA, which is Europe, Middle East, and Africa. So some of the markets that we serve here at Lighthouse are the semiconductor marketplace, aerospace, automotive, pharmaceutical, medical device manufacturing, and of course, why we're here today, horticulture. I think I have one more bragging slide here. So some of our notable clients in the life sciences division, some names you're likely familiar with if you've ever taken medicine or put on a Band-Aid: Bayer, Merck, Johnson & Johnson, Pfizer, Glaxo, Novartis. In the electronics and aerospace fields, NASA, Apple, Raytheon, Intel, Samsung, SpaceX, for example. And then, of course, in the indoor agriculture side, we've worked with Jungle Boys, we've worked with Suniva, Tweed, Cannabliss and Company, Cookies, and Happy Healing Farms. And again, this is just a very, very small smattering of our more notable clients. So let's get into the meat and potatoes of this, right? We're going to talk about microbe basics. So first thing we want to do is we want to get to know microbes a little bit better, all right? So how big is a micron, right? Microbes are typically measured in micron size. So the orange circle you're seeing is the cross section of an average human hair. So relative to the cross section of an average human hair, you'll see lint roughly around 25 microns, pollen can range around 10 microns, animal dander 3, same with like mold spores, for example. Bacteria, of course, are very small at half of a micron. So let's put that into perspective for a second, right? It's 420, take a deep hit, really visualize this. So to put this into perspective, what you're looking at on the picture on the left is the topography of a human fingerprint. So take a look at the tip of your finger, take a look at the tip of your finger, look at those little ridges right there, right? Those little ridges, a half of a micron bacteria would have to stack about 80 bacteria on top of each other just to be able to see over the top of a fingerprint. You see what I'm saying? So this is where, and we'll talk about this later, the importance of washing your hands and sanitizing your hands, because the average human hand has on average 10,000 microbes per square inch. 10,000 microbes per square inch. So there's a lot of surface area between the ridges of your fingerprints alone where these microbes can sit and can travel about a facility. The picture on the right is the edge of a piece of paper. That is the edge of a piece of paper under a scanned electron microscope. So you can see it's about 200 to 300 microns wide, thick, if you will. So to put that into perspective, if you were a 1 micron particle, if you were a 1 micron, like a mold spore or something like that, you standing next to the edge of a piece of paper would be like you as a human standing next to the edge and looking up the Empire State Building. Just to give you guys some scale, okay? We're talking about very, very small entities. So relative size of contaminants. I just wanted to share a few here that some of us are familiar with. Trichomes, 120 microns. Again, a human hair, 50 to 100. Pollen can range in the 30 to 50 micron range. Powdery mildew, of course, in the 30 to 50 micron range. Your skin flakes, 14 to 100 microns per. And by the way, allow me to just add as a note that skin flakes are constantly being sloughed off and shedded from our bodies. Just you sitting there right now are shedding 100,000 skin particles per minute. 100,000. So our skin definitely produces a lot of stuff. Where that becomes a problem is if bacteria, if they're large, if the skin flakes are large enough, bacteria can cling and take a ride on those and they float about the room, which again, we'll get to here in a minute. Mold spores can range 10 to 30 microns, though there are actually smaller mold spores. We should update that number, but you can see here that bacteria can go from 0.3 to 60 microns. A virus is very small, as you can see here. So again, to put a virus in perspective, if it takes like 80 or so bacteria to see over the top of a fingerprint ridge, coronavirus, for example, you would have to stack 2,000 coronaviruses on top of each other just to see over the top of your fingerprint ridge. Okay, and then of course we have pesticides and herbicides, which are incredibly small as well. So how small can the human eye see down to? So under normal light conditions, your eye can see down to about 35 to 45 microns. And that is like you just ate a carrot and you're in perfect sunlight. I mean, like that is the most optimal conditions under which you can see at 35 to 45 microns. So what we're talking about is a problem that you can't see, but you're still held accountable to it, right? So we have to act accordingly. So what does a pathogen look like at scale? I thought this would be pretty cool. So what you're looking at is a flea. Imagine the size of a flea for a second. Again, take another hit, it's 420, breathe this in. I'm going to show you exactly what you're trying to catch. So this is a 1 millimeter flea, right? So the thing you're trying to catch is not that diatom. Oh, no, no, no. It's that. That is the thing that you're being held accountable to from a compliance standpoint. Let's look at it again. Whoa, look at that. Bam. So I think the two takeaways again, microbes are very small, but I think the thing that this particularly reveals is that microbes that are harmful to your plants and harmful to people can ride on other entities. So you have to kind of consider that everything rides on the back of everything that rides on the back of everything. A great example of that would be how fungus gnats are really adept at spreading powdery mildew on their feet as they climb up the bottom nodes of the plants and start to spread. So that's one of the reasons it's good to keep your fungus gnats in check, because they're not only annoying and destroy your roots below the crown of the plant, but they can spread pathogens as well. So how do pathogens reproduce? Depends on the pathogen, but there's different methods. So what we're looking on the left here is Aspergillus niger. This is a mold spore. So mold spores, or mold reproduces by producing spores. So as you can see in this photo here, a mold spore will land. It'll develop a root inside of the entity that it's taking root in. And then it will go ahead and grow a stalk, or what's called a hypha. And then at the top of that, it will create a bunch of spores. So let's take a look at that and just, this is a 3D rendering of what Aspergillus niger looks like at its scale. All right, so let's take a look at this. So you can see these mold spores are just constantly flying around, and then those two bang into each other and bam! Mold spores. This is what makes Aspergillus niger so insidious. One of the reasons is that one hypha produces thousands upon thousands of offspring. So their reproductive rate is downright offensive at a certain point as far as our needs are concerned. So here, let's take a look at that one more time. Ain't that something? So it's really, really important that we try to capture these microbes and take care of them as soon as we detect them. And we'll get into detection methods here in a little bit. So other pathogens will reproduce by good old-fashioned cellular division. So this is E. coli, and you can see a time lapse here of what E. coli looks like. So it doesn't take long. They reproduce at a fairly quick clip. So definitely speaks to why it's important to keep your surfaces clean. So these spores and other pathogens are primarily in your air. That's the first place that they start. The dirtiest part of your room, the dirtiest part of your facility is the empty air void around the tables and around the plants, okay? So this chart that you're looking at here is the time for a particle of a known size to fall 1 meter in still air. So what they do is they set up some sort of glass tube in a laboratory, and they take, for instance, a 1 micron particle, and they put it at the top, and they drop it, and they wait to see how long it hits the bottom in an environment where there's no additional wind. So a 1 micron particle in perfectly still air takes 4.7 hours to fall 1 meter, and that's just in still air, in perfectly still air. So that means that it's not that these particles defy gravity by any means, but what it is at their scale, they're much more susceptible to environmental factors such as wind, you know? So in other words, these particles continually stay lofted in the air, and it doesn't take much for them to kick back up. So, and I'll tell you, here's why a lot of that happens. So on the left, turbulent airflow. This is what's typically going on in a cultivation facility. Turbulent airflow is air is flowing from any direction. It's constantly whipping around. It's kind of the nature of the beast, right? Because you're trying to pump in as much cool air as you can to overcome your lights if you're using HPS. But it's not just the HVAC system. It's also doors opening and closing. It is plants, moving about under the fans. It's the fans themselves. It's the people that are walking through, or they're pushing carts, or they're rolling stools, or they're reaching into the plant in order to pluck leaves, and they're moving air that way. So it doesn't take very much airflow to move or dislodge a particle. And the nature of cannabis facility design is such that you want as much cool air pumped into that room as possible. The result of which, though, is that the air is flying in every single direction possible all at the same time. Versus, pardon me, excuse me, versus what they do in clean rooms, for example, in pharmaceutical clean rooms, is what they call unidirectional airflow. And this is where they design their facilities where all of the air supply comes from the top of the ceiling of the room, and it's evenly distributed. So it's all blowing down at the same rate and at the same intensity at all points in the room. They build their returns in the bottom of the floor or down near the floorboards. And what you're not seeing on this picture is that those air returns actually go into a dead wall space, and that air flows back up to the top and then goes back down into their HEPA filtration. So they're trying to recycle as much of their own air as possible with as little makeup air as they can. And all of that airflow is moving at a consistent downward rate, to the point that in clean rooms, the way that they're trained to move about, they have to move about very slowly to create as little airflow and particle disturbance as possible. Because as we'll see later on, clean rooms kind of live and die by their particle counts. And that's what allows them to maintain their classification as a clean room. So we talk about particles with regard to like pathogens against our plants and as it relates to compliance. And somebody might be thinking out there, well, I don't have any mold problems, so I'm not worried, right? Well, allow me to just drop this on you, that particles in the room themselves are not good for the plants in general, even the ones that aren't necessarily pathogenic to the plant. So this is an article from a Science Alert, science.net, and this is essentially saying that the effects of dust particles on plants can have a detrimental effect by settling on the tops of the leaves, which, as we know, are the solar panel of the plant. These dust particles can also enter the stoma on the underside of the plant and create blockages there. And it might not necessarily be falling particle landing on leaf itself. And oftentimes what can happen is what's called electrostatic attraction. So meaning that it is like almost like a magnetized force, the way like a sock sticks to the towels when you pull them out of the dryer. So that said, dust particles in general, even if they're not necessarily containing a pathogen that might be related to the compliance itself, you still want to keep as much of your dust out of the room as possible, because you're trying to get the most out of your plants as possible. You're trying to give them the best chance for success. So before we go down the road of all the who's and the what's and the how's and all that stuff, I at least just wanted to address a high level topic that I'm often asked. And that question is why compliance requires microbe testing before retail sale versus some other agricultural product like lettuce or whatever's behind me right now. So, and that's a good question. And it's a frustrating question, but it's a good question. So the reason that lettuce, for example, you don't hear about a problem until they start pulling it off of the shelves is because lettuce, for example, is orally ingested. So because you're eating the lettuce, and ideally washing the lettuce before, at some point between the time it comes home from the store and the time that you serve it or prepare it. So lettuce is orally ingested. It goes into your mouth, meaning that as it travels through your digestive tract, the body has some natural filters in it that will help eradicate microbes that may be present on your vegetables. Your stomach acids, for example, your liver is a body's natural filter, and of course your intestinal lining as well. So This is versus, let's call it the devil's lettuce for today, that when a product is smoked, right, when it's actually smoked, it's going directly into the lungs, and those particles, if they're small enough, will go deep enough into the lungs to either lodge themselves in there to potentially become a problem. And like if you've ever heard of aspergillosis, which is a disease of the lungs caused by aspergillus. But if they're even smaller than that, they can go directly into the bloodstream and they can go directly into the brain. And these particles, as they build up over time, are widely known by the World Health Organization and other organizations like that, that particle accumulation within your body, within your bloodstream, can lead to strokes, can lead to heart attacks, can lead to diabetes, a slew of problems from taking in airborne particulate. That also being the case, that the standards for making something like a Tylenol or a Viagra, some sort of pill, they have one set of standards. But then you have the types of medications and therapeutics that are manufactured that that are not administered orally. So now we're talking like coronavirus vaccine. We're talking like Primatene Mist asthma inhalers, anything that bypasses the body's natural filters. In fact, the Johnson & Johnson vaccine that they just recently halted, I was just reading something right before this webinar that was stating that they're not necessarily calling out the efficacy of the virus so much as going to the factory facility by which it was made to do a full and complete audit of that facility to make sure that there was nothing involved in the process. Hence why particles and cleanliness matter. All right, so now why we're all here. So when it comes to microbe control within your facility, the first thing you want to do is you want to take a risk management based approach. That's how pharma facilities operate. That's how food facilities operate. And your facility wants to live somewhere between food and pharma. Obviously, the closer you can get to pharma, the better. I get it. Budgets are always an issue. But at the end of the day, how much of this can you apply to your own process that, luckily those standards are already in place. That's what's amazing about this. All this knowledge is here. You just have to be able to find the right sources for it. And here we are. So again, a risk management-based approach. So some of the main sources of contamination, some of the main areas of risk that you need to be aware of are people, your process, your equipment, the facility itself, poor cleaning procedures, and poor training of personnel. So we'll dive into these a little bit deeper. However, at the end of the day, as you're going through this risk management based approach, you want to be sure to observe your process. You want to make sure that you observe your employees. You're constantly looking for risks or points of potential contamination. And just know that risk management is an ongoing process. You always want to be ever vigilant for the way something can be done better that creates less cross-contamination. So here, let's see here. Let's go back to the next slide here. There we go. Okay. Did I do that? Yeah, here we go. Okay. So the first risk we want to take a look at is people. Okay, people. So personal hygiene is of absolute importance within a critical area like a cultivation facility. You want to make sure that your employees are showering daily before they come, or at least showering before they arrive. And as well, this is to eliminate any of the problems somebody might have at home that they can bring into your facility. For example, if you notice the picture directly to the right of the guy showering is a dog in an unmade bed. That kind of represents two risks that you want to avoid. Number one, pets. First of all, of course, you want to keep them out of your critical areas. But as well, you also need to be aware that when they go outside, they pick up all sorts of crazy, like between their paws and when they go rooting around in the dirt and then come back into the house. So, they don't know any better. It's the circle of life. It is what it is. The other thing to consider in that photo is those pillows. So some states are held to Aspergillus fumigatus. Aspergillus fumigatus, the #1 producer of Aspergillus fumigatus, is your pillow. Your bed and your unclean bedding is like the perfect fire triangle for breeding Aspergillus fumigatus, because you have the warmth from your body, you have your sweat, you have your drool, and then of course, you know, like all the little bed mites in there that are constantly dropping turds in there, like that's like perfect food. So you're creating this amazing ecosystem within your own bed, which means then that you must shower before you leave the house, and make sure that you're ensuring that you're the cleanest that you can be before you ever walk in the door. The other thing as well to be aware of from a people standpoint is people that have home grows. Now, I'm not against home growing. I can't do it myself because I can't be in microbe control tending to my home garden and then go into somebody's facility and typhoid Mary all my problems. But here's the thing, is that your employees are going to be doing the same to you. So I don't want to create necessarily like a discriminatory environment, but what I do want to say is that it is a known fact that eventually, if it already hasn't happened, that somebody that is tending to their home grow that shows up to work will invariably bring a problem with them, okay? Also, people become a risk when they show up unhealthy to work. If you're sick, stay home. If you have exposed cuts, cover them up and glove them over. People who have health issues, number one, are spreading pathogens throughout the facility. Cool. I mean, granted, most of those are affecting the people, but also depending on what someone might be sick with, they might start to make like poor decisions within the facility during the process, because they're just not completely in their right mind. They should be at home resting. And those problems can, you know, prove detrimental to the facility. Ask me about the time that I was mixing or filling the A and the B bottles, and I put A in the B bottle, and then they didn't find out about it until the plants started dying like a week later. Anyway, we live, we learn, right? Also, a people risk. A people risk is anybody visiting the hydro store during their shift. If hydro stores, great resource, great place to get supplies. However, unfortunately, a veritable swingers club of microbes from everybody coming in and asking questions about their plants and picking up their, you know, individual bottles of stuff. So I would say if you have the opportunity to open up a commercial account, I would do that and have these types of supplies either delivered or just go factory direct if you have to. It's not, you know, I'm all for supporting small businesses, but at the same time, if that small business is creating an environment that is detrimental to your facility's well-being, you still need the supplies. You just need to come up with more efficient ways to acquire them. So if somebody does need to go to the hydro store, they go to the hydro store after they leave work and do not come back until the next day after they've changed and showered. So just be aware of that. No more trips to the hydro store in the middle of the day, all right? Okay. So another risk we want to look at is process. So here's an example of a process, failing to properly gown. Now we've seen time and time again, I've been in plenty of facilities where everybody's dressed like Kyle on the left here. I don't know that his name's Kyle. He looks like a Kyle or a Todd. I don't know. He looked like Todd, Kyle. We'll settle that in the Q&A. Anyway, so people that are showing up in the street clothes and the street shoes are bringing all sorts of problems with them. It's not necessarily their fault. They're not necessarily doing it intentionally. However, as a facility manager or a facility owner, you need to be aware that, again, this is about reducing risk. It's nothing personal. Nobody's accusing anybody of being gross or dirty because we're all like that, okay? Like I said, 10,000 microbes per square inch on our hands. I have that right now. You have that right now, okay? We're all on the same playing field on that. So that's where facilities will want to set up a gowning area. A gowning area will be able to provide a safe space for you to don garb that will allow you to not shed your particles that you're bringing into the space into the critical area. There is actually a standardized way of gowning, if you will, of what they call donning. Removing of that equipment would be doffing, in case it ever comes up on trivia night. But as far as donning your PPE, you of course want to remove your jewelry. There is a lot of germs, by the way, under our rings and under our watches. I don't wear a watch, but you get the idea. So you want to remove your jewelry, you want to apply your hairnet, you want to apply your booties, you want to apply your gloves, your face mask, and your smock. We can have the debate about, smocks versus scrubs versus Tyvek suits in the Q&A. But in the meantime, just accept the fact that it's some sort of covering over your street clothes if you're not changing into something outright. Okay. So another area of risk management where contaminants can come into the critical area is from your equipment that's around the facility. So are you using designated tools? Are you keeping the tools from room 1 in room 1, and the room 1 tools do not go to room 2 or room 3 or the hallway or whatever? Every room has its own dedicated tools. That way you're not crisscrossing the facility, either looking for your broom or whatever it is you're looking for, or using it for that matter. You also want to create as much of a touch-free workplace as possible. Again, 10,000 microbes per square inch. Are you staying on top of the door handles? So there is a way to create a touch-free workspace where commonly touched areas like doorknobs and stuff are starting to become, thankfully, a thing of the past. We're not quite at the Star Trek automatic sliding door open. We're not there yet, but one day, right? Are you deploying sticky mats? You're like, what? Some of you may be like, what's a sticky mat? A sticky mat or a tacky mat, as it's called, is a mat that is super tacky. It's got multiple layers on it, probably about 25 to 30 different layers on it. And it is designed the tack on it is designed to pull particles off of the bottom of your feet. If you notice in this particular picture, the subject of the photo is walking the length of the tacky mat, and that is definitely essential for you. You want to make sure that you're putting both feet on. The technical way to do it, because I've seen people step over the sticky mat not knowing what it was, like trimmers and what have you. And really, in effect, what you want to do is you want to step, march in place, walk in. Okay. Also, be aware that your sticky mats also need to account for the travel of your cartwheel. So on your carts, a 6-inch cartwheel has an overall travel, if you rolled it out, of about 18.5 inches. So if you want to make sure that you get complete coverage of your cartwheels as you're going in, you either need to have a 19 or 20-inch long tacky mat, or roll it over a few times to make sure that you get as much adhesion as possible to get those particles off the bottom of the cart. Also, a lot of people, when you're done with a sticky mat, you will tear it off. But hey, be aware, okay? You're not just ripping off from the side. You're not ripping off from the side. You will dislodge particles that way, whether it's slow, whether it's fast. They've done studies. I can show you the data. What you really want to do, like when you have a tacky mat, is you want to pull from the corners and pull from the edges and ball it up into the center to create the least amount of particles dislodging as possible, right? So when you're taking care of a sticky mat, pull from the corners, pull from the sides, pull into the middle, ball it up. Are you using covered trash cans? I know, man, I'm getting way micromanager on this, right? But we are talking about microbes, so the micro part is totally appropriate here. Covered trash cans. So what are we throwing out in our trash cans? We're throwing out dead organic matter, depending on where the trash can is located. We're throwing out food. Sometimes you're not necessarily, like if you work in the office side of the house and you just, eat your muffin from 7-Eleven or whatever it is, and you throw it in your office trash can. That stuff creates mold, an opportunity for mold at the least. So to cover your trash cans is a safer bet than leaving your trash cans open, because those trash cans can contain mold that are releasing spores. And as we saw earlier, it doesn't take a lot of wind. You got to remember that a whisper to us, blowing out a candle, a birthday candle for us, is like a Category 5 hurricane to a mold spore. So it can travel very easily, get lofted out of the trash can, travel around, and all they're doing is looking for opportunity. Mold has been around for hundreds of millions of years, and it's done so by just being an opportunist. It doesn't have an emotion. It doesn't have a political affiliation. It doesn't care if you grow the most bomb weed ever. It is just doing what mold does. Full stop. Also, with equipment, are you using dedicated shop vacs per room? You know, when it comes to shop vacs, you know, you got to remember that that has a tremendous amount of output. So as much as you might be sucking up a bunch of problems through the business end of the shop vac, the output of that shop vac is also putting stuff out into the room, which is therefore putting stuff out into the air. So if shop vacs are absolutely necessary, I would suggest, in the name of risk management, that every room has its own dedicated shop vac and that those shop vacs do not transfer between rooms. I would also even go as far as to say that you may want to consider having a dedicated wet shop vac and a dedicated dry shop vac so that you don't create those mold opportunities, and change your filters often. If your facility is big enough to do so, I might even start looking into like a central vacuum system. This is basically like an outside of the building setup. Like it's a pretty large container with a lot of the ability to pull a lot of air, and they set up piping all throughout the ceiling of your facility and then drop piping into the rooms, and then you just simply attach a hose and a hose end and an attachment to the wall, and then you can vacuum up, and then now you're just rolling up the hose and putting that wherever you store that. So equipment is something you have to look out for from a risk management standpoint. Okay, so one of the other areas of risk management you need to be aware of is the facility itself. The facility itself. Now, let's remember, a lot of cannabis facilities were built prior to compliance, or they were built not long after compliance and did not necessarily have compliance in mind. This is a relatively new muscle that the industry has had to flex. So some of the things that we used to do in the days of past, in the days of yore, are no longer acceptable under the current compliance conditions. So for example, one thing that you need to be aware of is exposed wood. If you have exposed wood in your facility, you are creating a danger for your plants and your facility. Exposed wood loves mold, and it's very hard to get mold out of wood, okay? Organic equipment like bamboo stakes, as you're seeing here. If it's organic and it's not a plant, I would avoid bringing it into the room. In fact, for that matter, I would avoid bringing in anything that isn't absolutely necessary to the operation of that room. If you can keep it outside of the room, all the better. Some of us in the facility are using porous materials. Here you're looking at acoustic ceiling tiles. Some of you might be looking up at this moment going, yeah, I have acoustic ceiling tiles. All right, well, for one, you got all those little holes that are in the top, and those are just the holes that you can see. Those aren't the holes that other things can nest in that, again, are below the ability of the human eye to perceive. Also, with a lot of, and particularly with acoustic tiles, is they're made from organic materials like pressed woods and pressed cardboards. So again, you're creating a mold hazard there by having, potentially rotting organic matter within the facility. Also within your facility, be aware of cracks in your floors, cracks in your walls. You want to get those sealed up immediately. Again, at scale, a crack in your floor to a microbe is like standing at the bottom of the Grand Canyon and looking up, okay? And it doesn't, again, we're walking over those cracks, we're creating wind, and even though it might be living in that crack for a little bit, it might not take much to dislodge it and bring it out so that it travels somewhere else. Is your facility operating with rounded corners? As you can see here, this photo here, they've gone ahead and rounded out the corners. This is a very common practice in food facilities and pharmaceutical facilities. The object of the game being is that if you can remove the corners of your facilities, it makes them much easier to clean out when it comes to mopping or wiping something down. And what you're looking at, how that's done, is heat sealed vinyl flooring. that is what's called coved or brought up from the floor to the wall. And there's like a little plastic form that fits underneath the coving to maintain that round shape. So there's not like a dead gap within that rounding where it actually meets the floor meets the wall. It's a little piece of plastic that goes in there that helps round that up. Also within the facility, are you deploying proper air filtration? A lot of times HVAC systems that were spec'd into a facility were often done so in the spirit of climate control, right? Because that's the first thing you care about, is making sure that your lights don't fry your room. Cool. And there's plenty of HVAC systems that can provide that cooling capacity. But odds are, if you didn't look at the MERV rating of your filter or the level of filtration that's in that HVAC system, it could be very well insufficient for your needs from a microbial control standpoint. So let me jump back. If you're like, what's a MERV rating? MERV is the minimum efficiency reporting value. That is the rating system by which filtration, air filters, and air filter cartridges are measured based on the thickness of the media and what size particles that it can catch. So, for example, a lot of household and office central ACs are oftentimes MERV 8, which is great for pet dander and pollen and larger mold spores, stuff like that. If you can get to it, MERV 10, MERV 13 would be ideal. But even do consider that if your problems are 1 micron and up, that MERV 13 will still catch only 90% or up to 90% of 1 micron and up particles. So depending on what's going on with your facility, you may need to supplement with additional air filtration that may not necessarily contribute to the cooling of the facility, because you have that in place already, but it will just directly attack the particle problem itself. So finally, one of the risks to look for within your facility is water damage, right? If you have exposed water damage, I mean, you may have water damage in the walls, but you're obviously not going to see that until it's too late. But if you see any visible water damage, the object of the game is not just to paint over it, right? So that it's back to its pristine white again. You need to be able to treat that. You need to be able to investigate that. You need to see if there's a problem there. If you can eliminate if you can eliminate damage there. Sorry, I was looking at a text message that was coming in from the production truck here, and they're telling me to speed up. Okay, great. Here we go. All right, let's rock this. All right. Also, one of the risks: poor cleaning procedures. So understanding levels of clean. There is a lot going on here. Sterilizing, very difficult to do. You want to make sure that you are maintaining your contact time. So from an understanding levels of clean, you're looking to do disinfectant. Disinfection is where it's at. If you can get to sterile, great, but that requires a lot of extra effort. You want to make sure that you maintain contact time. That's on your labels. And you want to make sure you're policing fall and leaf bits. You want to make sure that you're employing proper technique, cleaning technique. You want to start from the top down. You want to start from the back of the table to the front, and you want to overlap by 20% at least. You also want to take care of biofilms. Let's see here. Let's see if I want to address biofilms for a quick second. This is the biofilm process. Basically, a bacteria will land on a surface. It will begin to form a goo around itself. Inside that goo will allow the microbes to thrive within there until such point as new bacteria break free and look for a new place. So they can live under dirt, which is why it's important to take care of your dirt, to do a surface clean before you do a disinfection. And so let's see what your cleaning agents actually do. I know we need to speed this along here because we have some Q&A stuff, but this is what bleach does under a microscope. I just want you to see this and visualize this. So bleach has been applied to this microbe. And as you can see, what it's doing is it is dissolving the membrane. And so when choosing cleaning products, you want to match the product to the pathogen. You want to understand the mode of action, how it actually works. You again want to use the proper contact time. You ideally want to learn if it conflicts with another product that you're already using. You want to begin to rotate your cleansers so that you lower bioresistance. You want to know any safety cleanup and use instructions. You want to document how and when you did the work. And if you could open up a commercial account with a cleaning janitorial supply that services food and pharma production, all the better. All right, poor training of personnel. Standard operating procedures. These are something that need to be built in. If you're looking for a way to build your SOPs, you can Google documents on that. You also want to start a complete an onboarding process that's consistent so that the guy who's a week into the job knows the same amount of information that the guy that is a year into the job. And how do you verify that? You verify that through competency testing. This is where you keep your tool sharp, so to speak. So let's see here. So you have microbes. Now what do you do? So you want to develop what's called a root cause analysis. This is where you look at the who, what, where, why, when. And this is a common, the fishbone technique is the way that one would be able to start to list out the factors. So if you're trying to decide what's going on with your microbe problem, you got 4 questions that you want to ask. You want to ask, where is your problem? You can do passive air plating where you put a dish on a countertop. You can do active air plating where you're pulling a very specific amount of air for a very specific amount of time. You can do contact plating, which is a plate that you just touch to people or touch to a surface, a table, a doormat. You can start to see what's coming in your building. Surface swabbing, and then there's surface tape lifting. So testing locations, basically anywhere where people come in contact with products. So floors, tables, walls, fans, hallways, gowning areas, what have you. Some suggestions on lab testing: partner with a lab that serves food and pharma. If they sell supplies, use theirs. Make sure they have an on-staff mycologist. Make sure that they can test for the pathogens you're compliant to. One thing you should totally be aware of is that total yeast and mold count will factor anything it catches within the test. Okay, that includes beneficials. And then I would do my testing early in the week and either overnight it or deliver it to the lab as soon as possible, because if you send it on a Thursday or Friday, it may sit in a box over the weekend if the lab's not open, and then you've tainted your sample. So question number 2, how did it enter the facility? Did it enter on tainted genetics? Did it enter on tainted media? Aspergillus is found in coirs and cocos all the time. Do you have a neighboring business that is pulling particles into your space that is surrounding your facility with particles? This is a brewery and a bakery. Keep in mind they have different handling requirements of their raw materials, which can affect your business. How did they enter? Maybe through an auditor or a visitor of some kind, to make sure that you give them extra special attention because they're not familiar with your process. Do you have any landscaping around the building that might be contributing to the problem? And of course, do you have any people that are working multiple sites throughout the day that may be bringing problems in from someone else or somewhere else? Question 3, how did it thrive? Did it thrive on dirty tools? Are you not cleaning your tools properly? Are you not cleaning up standing water? Are you not cleaning commonly touched surfaces? You want to know, where is it thriving? What's giving it the space to be able to grow? And finally, how does it travel? Your facility corridors are constantly crisscrossed, which creates a wide area of contamination. I've seen plenty of facilities where the rooms are clean of aspergillus, but the hallway has aspergillus, and that's just a problem waiting to happen. Is it traveling through your HVAC ducting? Is it traveling through crossing of tools? That's why in restaurants, for example, the cutting boards and the knife handles are color coordinated so that you make sure you're not cutting vegetables with a meat knife, or a cooked meat with a raw fish knife. All right. So what's the fix? I know this is the easy one right here, right? This is what we feel like doing sometimes. But fix number 1, facility design and retrofits. So if you have exposed wood, you want to epoxy that over or remove it outright and entirely. You want to use synthetic and non-shedding materials. You want to use positive pressure where you can, where you're pumping enough air into a space that when you open the door, air should flow out. We typically know negative pressure because we're trying to trap smell back in the days when we didn't want our home grows busted. Foolproofing the facility, meaning that, like, what's the number one thing that happens in hallways? People leave doors open. So if you can put something in there that automatically closes the door, bam, a lot of your problems solved. And then you want to try to set up linear foot traffic and scheduling your employees to keep them in one space for as much of the day as possible. Anytime someone crisscrosses an area, dirty to clean, clean to dirty, there's a potential to negate your microbe control program. Fix number 2, diagnostics, testing, and remediation. All right. Listen, we've done 30 slides of education. I'm allowed 1 commercial. Okay. Particle counters. This is a device that measures particles in the air. This is what clean rooms use to maintain their clean room rating. Supplemental air filtration, again, will constantly be remediating problems from the air. And of course, microbe sampling, where you're capturing problems on dishes and sending them to labs for analysis. Fix number 3, improving your cultural practices. So we're talking about proper hand washing. There is what's called the aseptic hand washing technique. I would Google it, I would download it, I would print it, I would put it above every sink. Also start getting into the world of documentation, documenting everything that you do. I know we're getting to some Q&A, so I'm trying to burn through as much of this as we can. We only got a couple more slides to go. So SOP reminder signage. This is super important. This is so you don't have to constantly police people. Hey, don't do that. Hey, don't do that. Hey, don't do that. If the signs are around the facility, they're very easily visible and very easy to understand. This will help reinforce the training that you've given them as you're cultivating your talent. So I would get to know, big picture, I would get to know 3 main areas that are used in food and pharma operation. Current good manufacturing processes, or CGMP. This is the standards by which food and pharma design their facilities. HACCP, which is Hazard Analysis Critical Control Point, is a way of being able, it's primarily used in food production to assess the contamination points within your process. These are all Googleable terms. They're their own books, but at the end of the day, we can get you to a point where you have what you need to know in order to thrive. And finally, CAPA, Corrective Action, Preventative Action. This is about what preventative actions can you take to prevent problems, and what corrective actions can you have on file and ready to go at the time that, that a problem occurs. All right. So in summary, in totality, the benefits of cleaner operation. You're talking about crop protection against foreign materials, bugs, mold, biocontamination. You're talking about increased yields. You're talking about possible reduction in pesticide and fungicide use, possible or reproducible product results, because you're doing the same thing every time, safer medicine, and happier customers, which means more loyal customers, which means profits. So that is the lecture portion of this. I did want to open it up to some Q&A, and I see in the chat window, let's see here. Okay, question number 1, and I know we only have so much time here. So how long can you use a sticky mat before tearing it off for the one underneath? I would say I would change them daily. I would actually change them in the morning. So the morning when you come in, because those particles have the opportunity to fall over the course of the night. Remember, a 1 micron particle, 4.7 hours to fall 1 meter. So you figure after you lock up the doors at the end of the night, there's no movement in there other than the fans, you know, the people are gone. So falling particles do have a chance to catch on that sticky mat. I would pull them all off as first thing in the morning and make them nice and fresh. Let's see. What do we got from another question? Should we use scrubs or disposable suits? Good question. You could go either way. It depends on your process. It depends on your needs. I mean, so scrubs, okay, are great because you're changing out of something completely into something else. However, with that comes the services that are required, like a uniform service. And if you do go with a uniform service, you do want to make sure that they package your uniforms like dry cleaning. I was right outside of a large-scale facility the day that their uniform delivery arrived. One of them blew off of the rack, landed on the ground, and what did the employee that was delivering the uniforms do? Picked it up off the ground, put it right back on the rack. We had no idea which one it was, right? So if you can get them dry cleaner style in plastic bags, all the better. Disposable suits, I've seen those used as well to great effect. What I will say is that, you know, yes, they'll be cheaper in the long run because they're disposable, but you are also creating more waste. Also, be advised that if people are using their street shoes inside of a disposable suit, like a Tyvek suit, over time, that shoe will wear through the material. So if you have the opportunity to supplement that with a bootie, like a slip-on bootie, I think that'd give it a little bit more durability. Let's see, what other questions do we have here? Andy says definitely a Kyle. I think so too. He definitely looks like a Kyle. What do I do about bathrooms that are in the gowning area? Okay, so some people built their facilities where bathrooms are in the gowning area or bathrooms are in the growing area, the critical areas, right? So with bathrooms, I would highly suggest that you negative pressure those bathrooms out the fart fan. I would do what I can to pull those out because someone uses the bathroom in a critical area. It's right in the main hallway. And as much as we hate to think about it, if you've ever seen one of those studies where they like show like how much is on your toothbrush after you flush a toilet, obviously those sharticles, for lack of a better term, will infiltrate your facility, and it's best to prevent the spread of E. coli and such by negatively pressuring out. And of course, remember keeping a touchless environment where you can. So if you can kick the door open, you can use motion activated sensors for your sinks and your soap dispensers and those types of things. All the better to reduce risk. Where can I find resources on how to get my facility to food and pharma levels? Okay. So there are a few different ways to go about this. So the nice part about these standards is that they're already in place. These are standards that the industries have been abiding by for decades. So the information is already out there. You just have to seek it out. So the first things that I would look for, I would Google the following things. I would Google from the FDA. Ready? Get ready to write this down. Actually, we'll make this available at some point. I'll take all these questions and answer them out as part of the follow-up on this. 21 CFR Part 211. This is the set of rules and regulations around finished pharmaceuticals, around CGMP. So these are the standards by which the pharma industry abides by, as well as the food industry, for safe handling and safe manufacturing. 21 CFR Part 211. Interestingly enough, there's another one that you may want to write down as well, and this is more future proofing, but it's called 21 CFR Part 11, just an 11, not a 211, just 11. This is electronics records, electronic signatures. So in a federally legalized marketplace, if the FDA is the one that is the governing body of this industry, they live and die by records keeping, validation, documentation. I assure you, auditors will be licking their chops at the opportunity to go in and find out that a facility has not been keeping records. So 21 CFR Part 11 is a way of codifying all the regulations that are needed in order for solid records keeping and how to do that. The other thing I would also Google is USP 797. USP 797. Excuse me. This is called the US Pharmacopoeia. USP, US Pharmacopoeia. 797 is the rule set for non-sterile compounding facilities, and this basically gives you a lot of the insights on how to build your flooring, what type of air filtration you should be using, like all those like details around facility build out. So if you can get compliant to USP 797, you will definitely be within the realm of food and pharma production, and that would be good. So So that said, we're coming to the end here. I know there's some questions that we did not get to. I do want to make sure that we get those answered. So we'll figure out a way to either, like I said, tag you in a post, or I'll reach out to you directly. But please do not be shy about reaching out to me. You can email me, jhadley@golighthouse.com. I'm also on Instagram as DyslexicsToner402 for anybody that gets the joke. And beyond that, we're at the top of the hour, and I want to say thank you to everybody for participating in our webinar, From Seed to Sale, Strategic and Tactical Microbe Control for the Commercial Indoor Farmer. And a special thanks to Clean Bud for introing me on the front end and acting as my fluffer there. You're amazing. All right, thank you. Have a wonderful day. Have a happy 420. Stay safe out there. Make sure you wear your mask, but make sure that it's accessible for smoking. All right. Take care, guys.